Capacitive Sensors in Manufacturing Industries Complete Beginner to Technician Guide. Welcome back to the Control Brainiac, your #1 channel for making industrial automation simple, practical, and fun to learn. If you're a student, a technician, an engineer, or someone already working in manufacturing or industrial automation, this video is absolutely for you. Today, we are diving deep into a sensor that is incredibly powerful, widely used across industries, yet often misunderstood or poorly applied. I'm talking about the capacitive proximity sensor. You may already be familiar with inductive proximity sensors, which are excellent for detecting metal objects only. But what happens when your application involves plastic, glass, paper, wood, powder, liquid, or granules? That's exactly where capacitive sensors come in. By the end of this video, you will clearly understand what capacitive sensors are, how capacitive sensors work, why industries rely on them, real manufacturing applications, advantages and limitations, proper installation and setup tips, common mistakes technicians make, and how to choose the right capacitive sensor for your plant. So grab a cup of coffee, get comfortable, and let's get started. What is a capacitive sensor? A capacitive sensor is a non-contact proximity sensor that detects objects by sensing changes in capacitance. Unlike inductive sensors, which can detect only metals, capacitive sensors are capable of detecting a wide range of materials, including metals, plastics, glass, wood, paper, rubber, liquids, powders, granular materials. In simple terms, if a material has dielectric properties, a capacitive sensor can detect it. This unique capability makes capacitive sensors extremely valuable in manufacturing industries where non-metallic materials are involved, which is honestly most modern production lines. From food processing to pharmaceuticals, packaging, cement, and chemical plants, capacitive sensors play a critical role in automation. Basic principle of operation. Now let's break down how capacitive sensors work in a very simple and practical way. Inside every capacitive sensor, you'll typically find a sensor electrode, an oscillator circuit, a signal processing or switching amplifier, an output stage, PNP, NPN, or analog. How detection happens. The sensor electrode creates an electrostatic field in front of the sensor face. When no object is present, the electrostatic field remains stable. The capacitance value stays constant. The oscillator remains inactive. The sensor output stays off. When an object approaches the sensor, the object enters the electrostatic field. The capacitance between the sensor and the object changes. The oscillator detects this change. The amplifier processes the signal. The output switches on. Very important point. The sensor does not need to touch the object to detect it. This non-contact operation makes capacitive sensors ideal for fragile materials, high-speed production lines, hygienic and sterile environments, applications where physical contact could cause damage. Dielectric constant explained. Very important. To truly understand capacitive sensors, we must understand one critical concept: dielectric constant. Every material has a dielectric constant, which determines how strongly the material affects an electric field. In simple terms, the higher the dielectric constant, the easier it is for a capacitive sensor to detect that material. Examples: air, very low dielectric constant; plastic, higher than air; glass, higher than plastic; water, extremely high dielectric constant. This is why capacitive sensors are excellent for liquid level detection. They can even detect liquids through plastic containers, through glass walls, without touching the liquid. This feature alone makes capacitive sensors indispensable in industries like food and beverage, pharmaceuticals, chemical processing, water treatment plants. Types of capacitive sensors. Let's now look at the common types of capacitive sensors you'll encounter in real manufacturing environments. 1. Flush, shielded, capacitive sensors. Can be mounted flush with metal surfaces. Have a focused sensing field. Less affected by objects on the side. Ideal for tight mounting spaces. 2. Non-flush, unshielded, capacitive sensors. Offer a longer sensing distance. Have a wider sensing field. Must be installed with proper clearance. More sensitive to surrounding objects. 3. Adjustable sensitivity capacitive sensors. Include a potentiometer or teach button. Allow fine-tuning based on material type. Extremely useful when detecting different products. 4. Analog capacitive sensors. Provide a continuous output signal. Used for level measurement. Common in tanks, silos, and bins. Capacitive sensor applications in manufacturing. Now let's talk about real industrial applications where capacitive sensors shine. 1. Liquid level detection. Capacitive sensors are widely used to detect minimum and maximum liquid levels. Sense liquid through non-metal tanks. Avoid direct contact with corrosive or hygienic fluids. Common industries include beverage bottling, pharmaceutical mixing, chemical storage. 2. Plastic and glass detection. In packaging and bottling lines, capacitive sensors detect plastic bottles, glass containers, transparent materials. Inductive sensors would completely fail here, but capacitive sensors work reliably. Point 3. Powder and granule level monitoring. One of the most important and most common applications of capacitive sensors in manufacturing is powder and granule level monitoring. In many industries, materials are not solid blocks or liquids. They exist as powders, grains, or pellets, and monitoring their level accurately is absolutely critical for process control, quality, and safety. Capacitive sensors are used extensively in cement plants, food processing industries, pharmaceutical manufacturing, chemical production, plastic and polymer processing. Why capacitive sensors are ideal for powders and granules. Powders and granular materials usually have low mechanical strength, irregular shapes, non-metallic properties. This makes them difficult to detect using traditional mechanical switches or inductive sensors. Capacitive sensors solve this problem because they detect non-metallic materials, do not require physical contact, work reliably in dusty environments, can sense materials inside silos, hoppers, and bins. Since powders and granules have their own dielectric constant, the sensor can easily detect their presence when the material reaches the sensing area. Common materials detected. Capacitive sensors are widely used to detect materials such as flour in bakeries and food processing plants, sugar in beverage and confectionery industries, rice and grains in agricultural and food packaging systems, plastic pellets in injection molding and extrusion plants, chemical powders in pharmaceutical and chemical manufacturing. Each of these materials interacts differently with the sensor's electric field, which is why sensitivity adjustment is so important in these applications. Typical industrial applications. Let's look at how this works in real factories. 1. Silo and hopper level detection. Capacitive sensors are mounted on silos, storage bins, hoppers. They are used to detect minimum level, empty warning, detect maximum level, overfill protection, prevent material overflow, protect conveyors and feeders from running empty. Because the sensor does not touch the material, there is no mechanical wear, no jamming, no contamination of product. 2. Feed control in production lines. In food and pharmaceutical plants, capacitive sensors monitor powder feed into mixers, granule flow into packaging machines, material presence before dosing systems. This ensures consistent product quality, accurate dosing, reduced material waste. 3. Dusty and harsh environments. Powder-based industries often have heavy dust, vibrations, high production rates. Mechanical switches fail quickly in these conditions. Capacitive sensors, on the other hand, have no moving parts, offer long service life, maintain reliability even in dusty environments when properly installed. Important installation considerations. When using capacitive sensors for powder and granule detection, technicians must pay attention to proper sensitivity adjustment, too sensitive false triggering, too low mist detection, dust buildup on sensor face. Regular cleaning is essential. Material type changes. Different powders have different dielectric constants. Wall thickness of containers. Detection through plastic walls requires recalibration. Why industries rely on them? Industries rely on capacitive sensors for powder and granule monitoring because they improve process reliability, prevent machine damage, reduce production downtime, increase automation accuracy. In short, whenever a process involves non-metal powders or granules, capacitive sensors are often the best and most practical solution. 4. Paper and wood detection. Capacitive sensors are common in printing presses, paper cutting machines, wood processing plants. They detect paper sheets, cardboard, wooden panels. 5. Presence detection on conveyor systems. Capacitive sensors are perfect for detecting non-metal objects, irregularly shaped products, items with low reflectivity. Advantages of capacitive sensors. So why do industries love capacitive sensors so much? Key advantages. Detect both metal and non-metal objects. Can detect through non-metal walls. No mechanical wear. Fast response time. High reliability. Ideal for hygienic environments. They significantly reduce mechanical failures, maintenance costs, production downtime, limitations and challenges. Of course, capacitive sensors are powerful, but they are not perfect. Limitations. Affected by humidity and moisture. Sensitive to dust buildup. Requires proper sensitivity adjustment. Can detect unwanted objects if poorly installed. That's why correct installation and calibration absolutely critical. Installation and setup tips. Here are some professional installation tips every technician should know. Keep distance from unwanted surrounding objects. Adjust sensitivity only after final mounting. Avoid unnecessary metal near the sensing area. Clean the sensor face regularly. Test under real operating conditions. A poorly installed capacitive sensor can cause false triggering, missed detections, production errors, inductive vs capacitive. Quick comparison. Feature. Inductive. Capacitive. Detects metal. Yes. Yes. Detects plastic. No. Yes. Detects liquid. No. Yes. Detects powder. No. Yes. Sensitivity adjustment. No. Yes. Final thoughts. And there you have it. A complete beginner-to-technician guide to capacitive sensors in manufacturing industries. If you found this video helpful, like the video. Subscribe to the Control Brainiac. Turn on notifications. Comment below if you want. Wiring diagrams, PLC examples, or real factory case studies. Remember, knowledge shared is power multiplied. See you in the next lesson. Stay curious, stay automated.